Assalamualaikum warahmatullahi wabarakatuh. Okay, so tonight, malam ni, saya nak explain konsep. Okay, just a concept on how to understand fixed end moment due to support settlement. Okay, fixed end moment due to support settlement. So, under moment distribution method, we will actually apply this into parts. Okay, number one, we will apply this in support settlement beam with support settlement. And number two, we will apply this in frame with side sway analysis. So yang ni just nak explain concept because macam mana kita nak apply fixed end moment ni. So always remember that fixed end moment ni, always mention fixed end moment is behavior. Bila the behavior means sign convention tu depending on the behavior, not assumption. Okay, not assumption. So for example yang previous one, due to external loading, we have something like this. Okay, so both end fix when we have load. Okay, the beam is loaded. Okay, basically dia akan bend lah, dia akan bengkok. Jadi dia akan bend, so fixed end moment ni yang akan give reaction ataupun akan counter back. Okay, dia akan apply moment, akan ada moment at support untuk counter back, means to remain equilibrium. That's why arah dia okay, as shown. But kalau due to side sway ni kalau due to support settlement ni dia macam ni. For example, we have beam. Kita nak try to understand concept beam with settlement. Okay, so kita ada beam macam ni. Okay, we have fixed, let's say fixed roller fix. Okay, adalah loading kat sini for example, or loading kat sini for example, doesn't matter. Okay, so the most important thing is loading memang akan remain dekat situ. So bila ada support settlement, kita akan ada additional. Means okay, akan ada additional. So for example, sini 50, sini 100 contoh. Okay, so dekat sini kita 4 meter length, sini 5 meter length, sini 2 meter, sini 3 meter. Okay, so sini A, B, C and D. Okay, lepas tu dalam soalan ada mention about support settlement. Okay, support B is settled or support C is settled. For example, support B is, tulis dekat komen dekat YouTube tu, dengar ke tak dengar, okay ke tak okay, clear ke tak clear. Okay, is, kalau ada soalan pun boleh tulis dekat YouTube. Support B is settled by, support B is settled by 20 mm. Okay, so ini additional external loading. So we need to always remember that FEM ni dia ada dua condition. Or dia basically dia due to loading lah, Now kita masuk yang nombor 2. So FEM due to delta. Okay, so kat sini delta lah, delta B is equal to 20 mm. Okay, 20 mm or 0.02 lah meter. Okay, so how to apply this into the diagram ni. So apa yang kita kena buat bila kita nak analyze beam with support settlement. Okay, so kita sketch free body diagram due to support settlement macam ni je. Okay, so dekat A tu remain, B ada settle. ada settlement. C remain at same position. D pun remain at same position. Jadi dekat B ni, dekat B ni akan ada, yang ni lah delta dekat sini. So dia punya height tu lah adalah dia punya ni delta B tu 20 mm. So C masih remain the same. So C masih remain. So C masih remain the same. A pun masih remain the same. A also remain the same. D pun remain the same. So yang mana yang ada perubahan? Only dekat B. Only dekat B. So we have A at same position. B, we have B and B prime. And we have C at same position and D also at same position. And always remember bila kita nak buat calculation FEM due to settlement ni or FEM due to delta ni, dia kan kita kena always compare, always tengok pada dia punya original position. Always tengok pada dia punya original position. So beam ni original dia horizontal. Beam original is horizontal. And settlement ataupun delta, dia kan akan always perpendicular dengan member delta. Delta ni, konsep delta ni, dia akan always perpendicular dengan member. Delta ni perpendicular. Macam mana nak tulis perpendicular? Perpendicular dengan member. It means that kalau beam dah memang kita tahu dia horizontal, delta must be vertical. Beam, this is for beam. Jadi where is the delta? So the delta is located here. Delta B. So this is equal to 0.02. 0.02 meter. 0.02 meter. Okay, 0.02 meter. Okay, now, so yang akan get affected, from the support settlement, yang akan get affected is member AB and member BC. Means that FEM AB and also FEM BC will have the FEM value. And there is no CD, there is no FEM for CD due to support settlement because CD remain the same, remain at same position. Yang berubah is due to delta B is AB as well as BC. So AB will have FEM, new FEM, and BC also will have new FEM. Okay, so how to analyze this? We do it one by one element. We do it AB first and then BC. So when considering AB, it is like this. Allah. Okay, it is like this. Always remember, as I mentioned just now, okay, original beam position is horizontal. This is original. And delta must be perpendicular. Delta must be perpendicular. So this is 0.02. 0.02. Length, okay, length is 4 meter. So this one is A, this is B and B prime. Okay, the most important part here is we have to put the right sign for FEM-AB. Okay, for FEM-AB. Okay, now let's look at the behavior. The behavior after settlement. And how the settle beam, okay, how the settle beam yang ni, okay, can go back to its original position. How AB prime as the new position, the new beam position, okay, can move to original position. Okay, can move to original position. Okay, how is it? We have to apply moment. We have to apply moment. So this is the new position. Always remember that original is horizontal. Original is horizontal. So how the beam rotates due to settlement? How the beam rotate due to settlement from original? Okay, we measure from original. It rotates clockwise. It rotates clockwise from original. Okay, the beam rotate from original, it rotates clockwise. It is about the rotation of beam before settlement, okay, at original position, move to new position. So due to this behavior, how the FEM, okay, look like? How will FEM react to this? Okay, FEM will push back the beam to its original position. Okay, the black arrow representing fixed end moment. Black arrow representing fixed end moment. Moment or fixed end moment. Okay, fixed end moment. Fixed end moment. Arah dia bukan anti, counter clockwise. Or we can say that when angle yang ni angle dia tahu. Yang ni dia punya angle. Yang ni dia punya angle. This angle is known as chord rotation. This is chord rotation. Okay, this is chord. Dalam buku ada chord rotation. This chord rotation ni measure the angle from original to new position. And FEM will push it back to its original position. FEM lawan balik. FEM lawan balik. Okay, FEM lawan balik sebab kalau kita ada macam ni. Kalau kita ada macam ni. Bila kita nak jadikan dia straight, apa kita buat? Bila kita nak jadikan dia horizontal, apa kita buat? Kita akan tolak sini, kita akan tolak sini. Barulah dia menjadi horizontal. Okay, dia akan jadi horizontal. So what can we conclude here is, okay, kita tengok pada rotation of beam from original to new position. Okay, the angle is called as chord rotation. Okay, chord rotation. And we can conclude as this. Okay, this one. Okay, chord rotation. When chord rotation is clockwise, FEM counterclockwise. It is opposite. It is opposite. Okay. So here we just need to identify like this. Identify from this. Okay, I measure here the original at point A and original at point B. A and B. A and B. A is okay. Original A is okay. The first point, the first joint, and then B has settled. Okay, B has settled. So at A we measure the original position or the reference line. The reference line at B also we measure the reference line, because this is actually the we apply the basic mathematics when we have angle and when we have Z. Okay, remember we have Z here. Okay, we have Z here. Okay, the angle is equal. The angle is equal. So the angle is positive. So automatically FEM is negative. FEM is negative. This is the concept. This is the concept. So when we have beam like this, okay, drop or has displacement, support settlement at one position, for example at B position like this. Okay, C will remain the same. Okay, A will remain the same. A will remain the same. Okay, so this is A, B, C, D. Let's say this is a 4 meter. This is 5 meter. This is also 5 meter. So what should we do is we will put another horizontal line at B prime position. Okay, this is to show the beam position. The beam position or the original position or reference line. Okay, reference line. So what we need to do is we should measure the chord rotation. Identify the angle for AB. For AB, the angle is positive for both. And for BC, the angle is negative for both. Okay, this is angle. Okay, this is angle. So AB angle is positive. AB angle is positive. AB, okay, the angle, okay, is positive. So FEM will be negative. FEM will be negative. So we just need to apply FEM AB equal to FEM BA. Okay, it is negative. So we should get negative. So we put negative. So the formula is 6EI for far and fixed delta over L squared. Over L squared. So we substitute this, we get negative 6EI. Delta is 0.02 divided by length. Divide by length, length is 4, 16. Then substitute EI. E is 200, GPA I. Have support settlement question, EI is needed. Okay, EI is needed because with EI then only we can calculate FEM due to settlement. FEM due to settlement. Okay, so I 510 6 mm4. Okay, let's check. Okay, E is 200 times 10 power of 6. And I Okay, EI. I is 500 times 10 power of 6 times 10 power of negative 12. And this is equal to, cancel this, cancel this, cancel this. This is equal to 200 times 500. So we will get this as negative 6 6 times 200 times 500 times 0.02 divide by 60. Okay, so this is FEMBA. FEMBA. Solve this, then we get the answer. Okay, what about BC? What about BC? Okay, let's check. BC. Okay, angle is negative. When angle is negative, FEM must be positive. Angle is negative, FEM is positive. That's the behavior. So for FEMBC, FEMBC, it is equal to FEMCB. Okay, it should be positive. It should be positive. So it is positive 6. E is 200. I is 500. Okay, delta is 0.02 divide by length. Length is 25. Okay, so we get this. We get this. And also we get this. Okay, so this FEM, we should combine with FEM that we get from loading. From loading. Okay, so that's all about the concept that you need to know before we can start doing any problem. Okay, for beam using moment distribution method. Okay, we must understand first how the beam behave due to settlement. Okay, and about FEM, we should know first about the angle, about the rotation, about the principle. So we have to always remember that the angle we measure from original to new position, means new after settlement. Okay, but FEM will react, will counter back, will push back the beam to its original position. So FEM always opposite with the angle. Okay, so that's all. I will give you the full example. Okay, by tomorrow inshallah. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.